In a previous part of this video, I went through one long example and showed on a graph how it would look like to solve a question where the coefficient is present and the period, you're restricted in the domain, or the period changes. So I'm going to do the same thing now, so I would encourage you to try this, but I like this question because you can solve it in two different ways. So you have sine, you have sine squared 2 theta over 3 minus 1 equals to 0. And this is restricted within 0 to 2 pi. So we are within the domain. We don't have a negative domain here, so we'll see if we need to actually subtract anything. But this is what we have. Now, initially I was like, wait, this looks like the Pythagorean identity. So you can solve it using the Pythagorean identity, and I would encourage you to do that. So to check that you can get to the same answers, especially if you want to practice a similar question. So just keep in mind that if you have sine squared theta minus plus cos theta, cos squared theta equals to 1. If I take the cos squared theta to the other side and 1 to this side, I'm going to get negative cos squared theta. So this whole thing is actually equal to a negative cos squared theta, so you can actually solve it with a cos. But I'm going to do it for sine, and then I'd encourage you to do it for cos. So our first step, as mentioned in the previous video or in the first slide, is you need to find your period, solve for theta, and then add or subtract the period that you found. So the period here is, we're in radians, so I have 2 pi over the coefficient. The coefficient here is 2 over 3. And solving this is going to give me 3 pi. So this period is actually stretched. This graph is stretched, so it only repeats at 3 pi. So what we're going to do is, so we're not expecting to find too many solutions as it's going to be stretched. So the next step is actually solve it. So I'm going to solve it for theta, and I get theta over 3 equals to 1, and then I'm going to take the square root, but be careful here. Some students do forget to do this. When I take the square root of 1, the answer is 1, but remember you're taking a square root, an even root. So when you take an even root, your answer is always a plus minus 1. Okay, and we need those plus minuses in these solutions. So now if I want to solve this, sine inverse, I'm just going to do the curly bracket to show the two possible solutions. I need to find these. So sine inverse of 1 is equal to pi over 2, and sine inverse of negative 1 is 3 pi over 2. Okay, then you can continue to solve it. So we need to solve it for theta. So 2 theta over, if you're confused by this notation, just look at this row individually or look at this row individually. So solving this, I'm going to get, so you're going to divide by 2 over 3, divide by 2 over 3 here. And the first one's going to give me 3 pi over 4. Divide by 2 over 3, divide by 2 over 3, and that's going to give me 9 pi over 4. So that having the curly brackets is simpler than listing the two possible solutions and taking up space. Now, what we could do is add or subtract 3 pi, our period, but you will soon notice that we will be out of the period, so it won't make sense. And 9 pi over 4 is already not within the domain. So if I add 3 pi, it's going to be even further out of the domain. If I subtract 3 pi, it's going to be further out of the domain. So it's not going to work. And then 3 pi over 4 as well. If I add anything or subtract anything, it's going to be out of my domain. So, so what we're going to do is just take this as our solution. So you can check with a calculator what this would look like, as in adding the period and noticing that it just won't fit, and this is already out of our domain. So 3 pi over 4 is the only solution. Now, it would make sense, as I said, the period is 3 pi, which means this is the function has been stretched. So let's see what that looks like. So sine squared 2x over 3, and then this whole thing is squared minus 1. And we want to see when is it equal to 0. We don't need to write the 0 there. We could just find the intersections. And we need to change our mode to radians. And we need to change our window. So we're looking from 0 to 2 pi. I'm just going to keep it at 0 to 2 pi. And our scale could be, I like 45 degrees as a scale, so pi over 4. And then the y could stay the same. So if I graph this, and if you notice, we want to know when is it equal to 0, and this is precisely when it's equal to 0. So if I go second, calculate, and I want to know the 0. So I want to know when does it intersect, at what y value is my x equals to 0, and that's 2.356, which if you take the decimal value of the 3 pi over 4, it is equal to 2.356. So it's equal to that value. So this is what we get. So you're basically just finding the roots of the equation. So hopefully visually this is clear. Always check your answers with a calculator if you can. And use the method. So the method would work again if your period has not changed, even if your period is 2 pi, but your domain is within a different domain or restricted domain, you can still add whatever period you have. So try and do it for negative cos squared theta. So you would write, so instead of this, you would get negative cos squared 2 theta over 3 equals to 0, and try to solve this, and you should reach the same conclusion.